Alright, this is lab 3. In this lab we are tasked with finding the unknown mass of a black hole using Newton's universal law of gravitation. That equation is the gravitational constant times our first mass times our second mass divided by the magnitude of the distance squared, and that would give us F net. Now obviously we don't know this portion of the equation. These are all the other information that we do know, though. We know what the gravitational constant of the universe is. We know what the mass of the star is. We, using VPython, can calculate the F net. And then also with VPython, because of that, we can also find the magnitude of the star's position. So we rework the initial equation with algebra and come up with this equation, which is the F net times the magnitude of the star's position squared divided by gravitational constant times the mass of the star, which gives us the mass of the black hole. So plugging in all of our known quantities, we get this. And we get this for the mass of the black hole. I should note that this is in kilograms. All right. So one thing that we did notice here is that since the mass of the two items, or the black hole and the star, are very close together, so obviously the mass of the star is 1.98 e to the 30, and the black hole is 1.981 e to the 31, this system should look more like a binary star system than a star orbiting a black hole. The give and take, the pull and the force on both objects would cause them to rotate around each other instead of just the one being the black hole being at a fixed point and the star orbiting it. We were posed a what-if question, and the answer is, what if the black hole had a different mass? Well, we wouldn't be able to, with the known quantities that we have and the known trajectories and the velocities, the mass couldn't change. We would not see a difference in the mass. If the mass were for some reason to actually be different for that black hole, we would either see it, if it was large enough, we would see it act what we would expect, which would be the star orbiting the black hole, not like a binary system. Since we obviously we wouldn't see an orbiting change based on the information we're given, then the mass couldn't change. And then also, how are F net parallel, F net perpendicular different from dp dt, dp dt par, and dp dt perp? The difference is that F net is our overall F net represents the overall force, where dp dt those just represent very small time frames, just points in time to take measurements from that give us our overall F net. So let's go ahead and open up VPython here and take kind of a look at our system real fast. So as you can see here, got the star's mass, got gravitational constant. Our delta t is 86,400 seconds, 1 day. Here you can see the CSV is being pulled, the data is being pulled from that CSV file. We had to figure out what delta y was in our y velocity. And come down here, we had to change several of our equations here for p hat, magnitude of dp dt, the parallel, perpendicular, the F net. Here we set the arrow scale. And then down here I had, we printed out the magnitude F net par, F net perp, and I also added in it to print out the equation to get us our mass of the black hole. So let's go ahead and run this and see what we get. So here we can see the orbiting path of the star around the unknown object. You can see our forces, parallel, perpendicular, and there we go.